So what you see here is the sodium benzoate in the beaker. Going to have 10 milliliters of water, and I'm simply going to add the two together. And then mix until the solid is dissolved. Kind of surprising just how soluble this sample is. It is a salt. Yeah, the cloudiness has gone away now, so this is completely dissolved. So now I have about 5 milliliters of the 3 molar hydrochloric acid. So hydrochloric acid, strong acid, plenty of protons. And what's going to happen is I add it slowly. We're going to see a precipitation reaction take place. And really what you're after here is just simply adding enough acid to push the pH to about 2 or so. And we'll test that with the pH paper in just a minute. Now we've clearly seen a chemical change here with the presence of a solid. But we want to make sure that we can get as much of that solid out as possible. And the way we're going to do that is to test it with the pH paper. And you can see with the pH paper, so we're looking for a red color on the pH paper to show that pH of 2. That would show us that there's clearly an excess of protons in the solution, and we can call it we can say it that the reaction's gone to completion here. Proper technique is to dip the stirring rod into the solution and then touch the pH paper. And we can see right now that, well, it's barely neutral actually, according to the coloration here. Even on the basic end, just a little bit. And that was with the addition of about 2 milliliters of the hydrochloric acid. And notice I'm not too concerned about how much I'm adding of the hydrochloric acid. That was another 2 milliliters, so I have about 1 milliliter left. I don't know if you can see in the video, but the solution is getting thicker. And again, test just a drop. It hasn't changed much. I'm actually a little surprised about that. So that's the full 5 milliliters of the hydrochloric acid. Now the white there is some of the solid that I've lost, so that's going to affect my yield just a little bit. But it looks like the total 5 milliliters have pushed it down to about a pH of 2 or so. I don't know how well you can see on the video, but that color is more red than orange. Okay, so if it was orange at 3 or 4 pH, I'd add a little more acid. I think that's enough. But just think about 2 milliliters added, 2 milliliters added, and it was still basically neutral, even on the pH basic side, just slightly. 1 more milliliter, and then I pushed it over. That's not unusual for a neutralization reaction like we're seeing here. And now it's time to filtrate it using the vacuum filtration system. Okay, so I have everything I need for the vacuum filtration. I have my sample in the ice water bath. I have a little bit of the solvent here. The lab calls for 5 milliliters. I have a little bit more in case I need that. I'll be using that to clean and rinse out the beaker once I transfer the solid. And I'll be transferring the solid into this setup with this funnel and the side arm here. Now I'm going to be using a water aspirator, and the way this works, this is just a normal faucet, and it's connected through what we call a water aspirator. As the water travels through this part of the apparatus, it pulls a vacuum on the tube, or the hose. The vacuum hose is connected to the side arm, and then that draws the solution down through the funnel. You'll see it in a second. Now when I clamp this, I always want to clamp my side arm, my receiving flask, and usually what I do is I place it in there and pinch my hand around the fingers here and then tighten up the set screws. Next, I want to attach my vacuum hose, and it doesn't have to go on too far, just as long as there's a firm fit. And then I want to use a gasket for my funnel. The funnel has little holes in it, and the filter paper goes inside there, and there's, you know, some appropriate size filter paper for whatever funnel that you're using. These are often referred to as Buchner funnels. If it's a conical shaped funnel, sometimes that's referred to as a Hirsch funnel. I'm basically ready to do this. Now, what I want to do is I want to prep this filter paper a little bit. Right now, if I just dump my sample in, the solid is going to go past on the sides of the filter paper. I actually want to use water, since I'm using water as my solvent in my sample here, and I'm going to use water, use this appropriate solvent to then stick the filter paper to the funnel. I'm going to turn on my faucet. And then if I just gently push down on it, the vacuum will be set up in my flask, and then you can see the liquid being pulled through. There we go. I don't know if you saw that, but the funnel then, filter paper actually stuck to the bottom of the funnel a little bit better there too. You may have picked up on it, the sound of the aspirator changes once the vacuum is in place. And now I'm ready to filter my sample. And it's fine just to dump it all out at one time. I'm going to try to use a little rubber tip to get out as much as I can, but honestly, the best way to do this is to use the cold solvent, okay? So the reason why we cool the solvent before we clean the beaker out with it is to minimize the loss of the sample, right? Cold solvents tend to dissolve less of the sample. Pretty clean so far. I'm not too worried about the solubility here. I think it's fairly low. I'm actually going to use that to also clean off the tip of my stir rod. Now ultimately, in any kind of experiment, you're going to lose some sample here. Honestly, I think that's fine. There's a little bit of powder there. I'm not worried about it. I'm not even worried about that. Now I'm going to pour some solvent over my crystals or my powder. Break it up just a little bit. The solvent here is designed to wash, excess salts out of your sample. Now our goal here is to dry that sample until the mass is constant. Now I can leave the water aspirator on for a while to draw air through the sample. That does tend to dry it some, but for this experiment I'm going to go ahead and stop the water aspirator because this is fairly loose and powdery now. Here's my pre-weighed weigh boat. I'm using the aluminum because I'm getting ready to put it in the oven. Now when I transfer this, well, you just have to do the best you can. And just be patient with it. Now I have loosened up the filter paper. I'm going to go ahead and dump that out as well. Fairly clean. I'm going to call it. So again, anytime you transfer a sample, you're going to lose some of it. That's just part of the game. I did lose a little bit on the counter there. I'm going to collect that. A little bit of powder there, I'm not worried about it. I'm not even too worried about what's on the stir rod here. I just want to get it basically cleaned off without scattering the powder too much. Still damp, I need to dry it in an oven. And so what you're going to see in the next series of images is just the initial mass of this sample wet, and then progressive or masses as I progressively heat the sample and drive off the water. And at some point there'll be a constant mass, meaning I leave it in the oven for 5 minutes and the mass that is lost is very, very small, indicating that no more water is being lost from the sample.